This is the third Glowscript tutorial. It will be a short one to show you a little trick that would have helped some of you realize that your distance of closest approach wasn't what you thought it was. So here's a program. Run it. And as done in class, the asteroid turns red, and to see the closest approach we had to go to the output window over here and scroll up and find it. In this case, the closest approach was 1.51942 times 10 to the 8th meters, but we had to kind of search for that, and you might miss it. So here's a little trick to make the computer keep track of that for you. What we're going to do is, I'll go to the end of the loop here, line 33, hit enter a couple times, and then backspace, so that now it's not indented anymore. So this will happen after the loop is over, after the program has done its hard work. And I wanted to say print, because I want to print, in quotation marks, closest approach was, move over, comma, and let's call this D min. Okay, now of course if I run this, it does not do so because it doesn't know what D min is. Okay, let me zoom in here a little so you can see what I'm doing a little better. Okay, so it didn't print anything because it doesn't know what D min means, so I have to do two things. First up here, after I've created the Earth and the asteroid, I need to go ahead and calculate this relative position. So I can copy that from line 32 down here. And I'll put this up here at the end of line 10, hit enter a couple times, and paste it in. And at that moment, d min, the closest approach, is what the distance is then. So it is equal to the magnitude of this relative position vector, mag rel AE. Okay? So that establishes what d min is at the beginning. Then go back to line 35, hit enter. Now I have to say, okay, maybe the minimum distance at this moment is smaller than what it was. So I will take d min and set it equal to the minimum of what d min is already, or what the magnitude, the distance is now. So again, on the right we take the value that's currently stored in d min, do this calculation, and this function min will give us something that's equal to whichever one is the smallest, either the old smallest distance or the distance now if it is smaller. And this will continually keep d min to be the smallest. Hoping this will work. Save. Run. And here it says closest approach was 1.51942 times 10 to the 8th. And if we look back, that in fact was the time of the distance of closest approach. And there you go. One small thing, the times that have been printing out have been a little off. Really, it would be best to update the time at the very end of the loop. So I'll just make that change because I noticed the times look like they're always a little off. Clean things up a little. And save again. So now you don't have to go scrolling through, but, oh, and what did I forget here? Think for a second. That's right. A point off for not putting the units. So I'll go back to line 39 and add that this is meters. Save. Run it. And everything is good.